Hi, everyone. I am Cesar Loli. I am going to talk about the latest updates we have done to Wolfram geography and the things we have done in that subject to support historical computation. What is our aim with this? For long, we have had in Wolfram language the capacity, the capability to use geographical functions and do calculations on them. It has been our group's aim to strive for including historical information with these computations. That is, that we can make calculations in order to learn more about history, teach it better, or make some new results based upon them. We can use the functions we have now on the Wolfram language, such as the uh, functions to create maps and charts, in order to visualize and to order to better visualize history or other historical topics. As I said, the first thing we can talk about is about historical maps. We have long had the tools to draw maps of countries, administrative divisions, but we had the issue with historical countries that these were maps that changed with time. So we had to include new functions, new properties, and new geovariants in order to make them accessible to the user. For instance, we have here the most basic one is the time series of polygons. These allow us to represent how an historical entity might change over time. For instance, we have here the Roman Empire that has not one map, but many. And we can see how this entity has changed over time. With just a few calculations, we can do something like this and see how the area that this empire covered changed over the centuries. We can see here, for instance, where I am pointing, the famous 3rd century crisis. Here is the maximum expansion. This chart itself talks to us a lot a lot about history, more than any single map could do. This time series can allow us to compare maps from two different times of the same entity or different entities. We can here see the great difference that we have seen in the chart, now mapped geographically. The other form that we can represent maps is by using the maximum expansion. Maximum expansion, what it gives us is one single map that will represent the entire entity. This map will represent the moment in time where this entity was at its maximum area. For instance, we can see here that it was for the Roman Empire in the year 117. This, along with, for instance, the options in GeoBackground, can allow us to see how the world was like in that year and how the entity looked compared to the other countries. This we can mix with the wrapper dated. The idea of the wrapper dated will be to narrow down the space where the entity is defined, well, the time, to a more specific set of times or a more specific interval in time. We are no longer calculating what is the maximum area of the Roman Empire in all its history, but what it was its maximum extent in a given period of time. For instance, we here can see that we can calculate upon the maximum expansion. We can see the maximum expansion date between these 2 years, 270 and 274, and we can see that the area is much less reduced. The idea with these maps is to combine the wrapper dated with all possible geovariants. With the previous one, the time series, it also can be done, only it's pretty trivial. Oops. Finally, with this historical map, the other way we can map a historical entity is to have a polygon that is, in essence, the union of all the polygons assigned to it. This can also be interpreted as all the areas that have at one time been covered by that entity. We can here, for instance, compare the difference between the maximum extent and the union of all polygons, the union area. Because even if the maximum area has the largest possible expansion, we can see that the Roman Empire did not have all these territories at the same time, which explains why we have a different shape. This, as much the same as with the maximum expansion, we can narrow down using data. We can seek out an interval in time and have all the territories covered by the entity in that period of time. Now, this have basically been maps. We had much of that the last time I did one of these. The only thing is that now we are displaying them in a more appropriate fashion and computed fashion. But our biggest change is the kind of calculations that were previously only available for geographical queries. For instance, we have long had these types of queries, like in which country is this city located, or where I am. We have here, for instance, that we can seek out in which country is the city of Rome located, or use another domain, such as administrative division, and returns us all the districts in which the city is located. Now we have extended, in the most easy way, at these two historical countries. Then we can see that these are all the historical countries that have, at one time or another, contained the city of Rome. However, we can use the data wrapper much the same way as we did with the polygons in order to narrow down the result to a specified date. For instance, we can ask in the year 600, which historical country contained the city of Rome. And it will seek among these shapes which of these contain the city of Rome in the date that we are given. something you can see here that we can also use the dated wrapper in the domain. In order, what's the difference? In order to have the function return a dated wrapper. This will allow us to not only know which entities have we sought, but also in which times did the entity contain the point that I am searching. For instance, this allows us to see a timeline of all the historical nations that have contained the city of Rome with the times in which that happened. We can see it here a bit more visually. You can see here also that there are some times, like for instance, the Ostrogothic kingdom, that it's twice as it is interrupted by another entity. Because we are saying not that these are the countries that contained it, but that these are the times in which it was contained. We can use this not only to use with all, as I did before, and to give me the entire timeline, but much in the way I did with the polygons before, in order to narrow down to a specific time. For instance, I can use the information we have in the historical period to narrow down in which countries was the city of Rome contained within the early medieval period. And we can return a similar timeline, but far more readable. Now, an important thing, I have only shown so far historical countries. So far, the domains that we have with historical support are only military conflict and historical country. Military conflict are mostly expressed in the form of positions with a date associated, date or dates. So we can, for instance, if we have a non-historical entity, such as one as the city of Rome, which is only considered geographic, we can calculate what are the nearest military conflicts that were fought to the city. As we can see here, these are pretty close by. But if we use GeoIdentify in order to identify which historical countries these conflicts occurred, we see here that the entities are not only matched in space, but in time. We are seeing here that each battle is not only considered by their geoposition, but by the start and end date that it happened. And so the function is searching in the database for those entities that at the time of the conflict contained the space of the position of the offset conflict. In here, then we can see how the different military conflicts are aligned to different historical countries across time. We can take one of these battles and use our other function, GeoEntities, to see how was the world, or well, Italy, like in the time period of the battle. We can see here then all the historical countries that were located inside the territory of the modern nation of Italy. Using GeoList plot, we can see how it was divided among several nations then. We can use the data wrapper that is returned by the function, the data wrapper with the specific date, in order to plot the polygon, the specific polygon that we want in that time. We can do this. I am doing here this with countries. We can do this with administrative divisions, etc. We can see how Germany was in the year 300 BC, etc. These types of calculations include both computations in time and space. We can see here how geodistance, for instance, is calculated. We can calculate the geodistance, that is the minimum distance geographically between two regions of space. And we can calculate, for instance, in a single date, how were these two nations, the Roman Empire and the Han Dynasty, separated. We can do this for large amounts of time. So we can see here, again, a time series. We can see a chart with how the distance between these two nations grew longer and shorter across time, depending on the expansion of these two kingdoms. We can here then see how the distance that is calculated when the entities are given without any wrappers is the minimum distance that have at one time being the distance between these two nations at the same time, which is completely different from something like this. I am doing here using the geovariant union area that, as I said before, represents all the possible territories covered by a single entity, and we can see that the distance is much lower. As here is the minimum distance between 2 points that have belonged to any of these entities in any point in time. It doesn't have to be simultaneous. One of the most interesting things we can do with this is that we have in Wolfram language a lot of functions that make use of geographical calculations. For instance, we have here travel directions that we can use to locate a path between 2 points. We can use this path and see which historical countries it would cross in different time periods, in 300 BC, in the year 100, in the 1300s. Another possible interesting use is, for instance, with the information we have on solar eclipses. We can here, for instance, Remember the famous eclipse predicted by Thales in the year 585 BC? We can, with our functions in the Wolfram language, calculate which was the path of the eclipse, where it was seen, and then we can use this information, that is, of course, geographical and historical, to see in which countries did this eclipse was seen through and at what times. So we can see here in the year 585 BC how these countries, from these historical countries, the eclipse could be seen. We can see here a map of the historical countries and the trajectory of the eclipse. Now, as I said, the point of all this was to combine the data we have already on historical stuff, and use the powerful functions we have for geographic calculations in order to make new computations that can give us a new perspective on history. This is, of course, a work in progress, and we are happy to keep working on this and keep expanding. For now, we have only 2 historical domains, but we hope that in the future we can add more information so we can make better and more complex computations. Yes, well, that would be all. I've seen some questions. Yes, I can share the presentation notebooks. I presented them with the team, but I think they haven't posted them yet. But I have the notebooks, and there is no problem with that. Yes, the citations. This is something we are hoping to add. This is a great question by Mike S. This is something I'm hoping to add because, as for now, it's not too serious to have information without the sources. So, and the thing with history is that we have many times many conflicting sources. So we are thinking of ways in which we should expose the use of these sources to the user, so that the user can see, like as I said, I did with the date in the maximum expansion. It would be excellent to have the user have the source for each map, for each reference, and even use maybe geovariants to make different computations depending on the source. It's something we are working on. We have a large room to expand. Yes. think that would be all. Yes, for calling the historical entities, it's as easy as to do something like this. Also, you can do the same stuff with the if you for instance, there are entities with similar names. If you want a specific entity and you have problems locating it by name, you can certainly use our geographical function. For instance, if you want the Kingdom of France at the year 1300, we certainly know that Paris is part of the kingdom. You can see here which one is it. Sometimes, for instance, we can have problems with stuff like the United Kingdom, that we can have many entities for one single historical country. As you see, the United Kingdom of Great Britain and the United Kingdom of Great Britain and Ireland are two different entities. So sometimes the geographical functions could also be a good way to calculate or to find a specific entity that you want. Ah. I think one is Tunisia. And the other one I don't exactly know. My son is a great fan of flags. Well, if there is any other question, yeah, I think okay, well, goodbye.